Hi, everyone. Welcome to the Future Construct podcast. I am your host, Amy Peck, and today we are talking to Ron Mann, who is the Vice President, Modular Systems at TDIndustries. Welcome, Ron.
Thank you. Glad to be here.
So before we dive into your role at TD, which is a big and busy one indeed, how did you get into this industry? And then specifically, it seems like you took a turn at one point, like more focused on data centers.
Yeah, it's an interesting story. I started out at actually Compaq computers back in the day, and kind of morphed into when HP bought Compaq. I was doing a bunch of new product introduction work, bringing new products, servers, and things like that to the obviously to the community and the consumer. And then there's an opportunity came up to kind of do this thing called a rack. I don't know if you knew the history, but Compaq actually invented the first server, which was Server Pro back in the day. And then we had one of these big customers in the West. We said, we're tired of putting these big tower servers on these bread racks. What if we put them like in some kind of a rack thing? And so that's how the whole thing kind of got started. And we just turned this server around and put a different kind of bezel on it and put it in this rack. Looked up a company who did industrial type racks. The computer racks didn't even exist back then. And then it just kind of went from there. And then we kind of created a whole product line and morphed into first just standard racks. I mean, if you go back in the day, the racks even had plexiglass on them. Because the airflow wasn't a big deal. So it got into all sorts of things. And then we started doing, well, how are we going to power these things? We got into power distribution. What about backup? UPSs. And it just kind of morphed into a whole business for Compaq at the time and then HP. So it was very exciting because we did a lot of what I think very innovative things. What I've learned from all that is being on the IT side, we weren't doing this just because we wanted to be innovative in that space. We did because we're trying to sell IT, and the structure just didn't exist. So what we did is we worked with select partners in the industry, whether it be a UPS provider or a rack provider, and help a lot of these guys. We kind of got them started in the industry and really took off. And we just started developing these things and saying, hey, we got a server that's going to come out. It's going to be doing 1,000 watts. What? Oh my God! Well, we need a power distribution system. We're going to put 4 of them in a rack. And then you got started by U size, right? And an interesting thing is, like, if you go back into the original racks, they had these big cathode ray tubes. Remember those? The big tubes, the big screens.
Well, everything was giant.
Exactly right. And then Compaq came out with one of the first flat screen monitors for the PC group. And we said, hey man, what if we put that in a rack? So it's a 2U device. You can fold it down and save 4 or 5U to put more computer space in. And so that's the kind of stuff that we just did over time that became really interesting. It became a pretty big business for us. And then that eventually morphed into basically modular. Gee whiz, if you can put a server in a rack, why can't you put it into a module and ship it all loaded? And so we did fully integrated racks, fully integrated modules, shipping to customers. We had customers that would actually come to our factories in Houston. When I was at HP, we would load up this stuff with all the IT in it. The customer would come in, load their software, and test it and validate it. And literally, it would go to the site, plug and play.
That's amazing.
So it's a lot of firsts, a lot of industry firsts. Very creative people. I'll have to say that Compaq HP was probably one of the best jobs I ever had on the innovative and creative side. So it was a great ride.
That's great. Well, I think there's a couple of things. I mean, that's a great example of the need shaping the technology and the utility, right? Which I think is always the best approach. But it was also, I mean, that had to be before people were really talking about data centers. We all talked about the cloud, but we didn't really even know what that meant, that it was just these racks of servers, somewhere out in the desert or somewhere in Finland, right?
That's exactly right. Yeah, that was the whole thing. It was a whole new industry, how they created it, what we did with it. I remember we were sitting there, and this is before even in HP, because we were an IT company, right, in Compaq. So we were about servers and storage. So even infrastructure wasn't always on top of mind. How it was going to be implemented. I remember one time our general manager at the time said, "Hey, we're going to start doing integrated servers and racks." And their thinking was, why have all these boxes, 100 boxes that come, all these servers, unload them, have to put them in a rack on site? Let's integrate it all on site. And we thought that was a great idea, but I'm thinking, well, we don't even have a rack can do that. How are you going to ship it? I mean, think about it. If you put a load of racks, a load of IT in a rack, it's a small car on 4 little wheels rolling around.
Yeah.
So we had to develop a whole different technology on how to roll these racks around, how to integrate them so they would survive, and then take that one step further into the module, same type of thing. When you did a bunch of those in a module, so all that just kind of had to be invented as we went along. So it was just, you're right, but people just didn't think of it that way. It was just a whole new world. And you mentioned cloud. That's interesting because people didn't know what the cloud was. Or I remember going to industry events and everybody had a different definition of what the cloud was. It's sort of like kind of edge today, right? If you talk about edge computing, what's that mean?
Or like anything, like metaverse, everyone, and Web3. Like
exactly right, exactly right. New acronym, but it all has a foundation. It all has a reason, and it's just how you apply it. My biggest learning again is it's all about the application. What I tell people even today is there's a lot of people out there who want to take something and do something with it to support data centers or construction, or whether it be traditional data center construction or whether it be modules, whatever you want trying to do. But the thing that I think a lot of people miss, especially if you're getting into this space, in a modular space, is application. If you understand the customer's application and what they're trying to do, and make sure the infrastructure surrounds it, because think about it, the IT is just it's an ecosystem. It's the brain, and the rest of the infrastructure, being the rack, the power, the cooling, that's the body, that's the heart, that's the lungs, and all that has to work together. And the more you optimize that for the use case, don't over provision, don't under provision, the cheaper it's going to be and the more cost effective it's going to be, both to implement and to support.
So not just by your history, obviously it's clear where you got your geek stripes, but your geek stripes really, I think the origin story might be right behind you. Can you tell us a little bit about what's going on back there?
Oh, yeah, that's the little model I did a while back, USS Enterprise. I've always been a sci-fi guy, so I like to, this world's pretty stressful at times. So when I in my leisure time, I like to get off the planet for a little while, and so I read a lot of sci-fi. I was a fan of this stuff back in the '60s when it was on. I was just a kid then, but I just remember it. And you can't see it, but I have a Star Trek tree over here on the right in my home office. It's full of every Star Trek ornament that's ever existed. And so it's just one of those things that I think, because I do think if you look at some of the technologies that are coming out, if you go back to the original Star Trek, the little plastic wafers that were supposed to be for data. Look what we got now.
Yeah.
Cards, USB. It's all there. Communicators, the smartphone, the cell phone. It's all there. So it comes to fruition. It's interesting how it parallels.
Yeah.
So
yeah, I totally agree with you. I think, I talk about, the art imitates life and life imitates art. A lot of science fiction is the path that we take towards the future because it makes sense. Someone has kind of created a visual cue. And I think Star Trek and a lot of science fiction movies, you look at the metaverse now today, that, came from Neil Stephenson's book in the 90s. So yeah, I agree with you, but I think it's really interesting that I think that there are a lot of people today who are in the careers they're in because of Star Trek, and so that's why I was fascinated that that's back there.
I totally agree. It's amazing. And what's nice about Star Trek, it's not only because of the adventure and things, but it's just it's the vision of the future. We take care of a lot of our problems. They don't have any sickness in the future. No one's fighting wars like they do now. It's just amazing. So that's an idealism. May never be true because we're all humans and things are that way. But it's nice to strive for something better than what we have today. And so I think that's another big message that those kind of shows do.
Yeah, I agree with you. And then on the technology side, data centers are kind of everything right now. The level of data now that's going to be coming off of these next generation devices. You mentioned edge, cloud compute. We have real-time rendering. We have Nvidia being able to do, like fully rendered cloud simulations. It's mind-blowing, the level of technology, but also the level of data that comes with it. There's Moore's law, right? In terms of optimization, and you've probably seen all this optimization happening. You've been part of the optimization, but is there a point at which we fundamentally have to think differently about how we work with all of this data and this technology? And is it going to be the data centers that we know today, or are they going to be on a little wafer?
I think it's going to continue to evolve. What's nice about being in the data center space or the IT space is it's always innovating. It's always changing, and they're willing to take new challenges and sometimes risk on new technologies because they see where they have to continue to support this stuff. I think it's going to continue to evolve. I remember having discussions probably 10 years ago, talking about, like even today, if you look at a rack, and I always like to go by watts or kilowatts per rack is the standard, but 10 kilowatts per rack or less is typically what a data center will support fairly easily. And I remember having these discussions 10 years ago in these conferences about how it's going to be 20 kilowatts a rack, by this time, and it's still not. But what's happened is, and the reason why it hasn't gotten there yet, but it's getting there now, is because the IT industry continued to gain innovation and efficiencies. I mean, if you go back and look at a 1,000-watt server, one processor, it may have been only using 30% of its power back then. Now it's using 95%, multi-node, multifaceted, Nvidia, all that's, like you said, all the stuff you're doing with GPUs and CPUs. And so they're fully utilizing that space now that they weren't doing before. Blade servers is an example, all these things that have evolved. But now that limit's being reached. So I think the next frontier is going to be, data is going to continue to explode, both for analytics and data crunching and memory and storage, all the things that we do. But I think the next really thing is what's the way to make it more efficient? Because we're still using air cooling on a lot of this stuff. And air has always been a good insulator. It's been a lousy conductor, but we keep using it as one. And the main reason is because that's how the whole thing got started. I mean, keep in mind, go back to the original discussion. The server started out as a desktop, and it was just, hyped up desktop. And in air, everybody knows how to use air, but it just comes to a point where, it's not as efficient. So you hear things about immersion technologies, either single or dual phase immersion, cold plate cooling on processors, all sorts of things you can do to better remove the heat. Still use air, but not in the same manner. And I think that's kind of the next frontier. Power consumption is a big deal. Whether you use green or just standard power, and how do you make it more efficient? And that's where I think densities come in, because actually in these modules, some things that we're doing here at TD, you actually get more efficiencies by going higher kilowatts per rack in a module than you do spread it out. I've had discussions with customers who'll say, "Hey, I got this application, I got 20 racks, I want to put it in a module." And I said, "Fine. What's your typical standard watts per rack?" I'll say, "Oh, 7 or 8 kilowatts." I'm like, I can do that in 10 racks or less and do it at 20, 55 kilowatts and save you a bunch of time and money, and it runs better because it's more efficient. And so those are some of the paradigms I think that people have to rethink as they go through this. So it's not a matter of just taking a traditional data center thing and throwing it in a box and calling it a module. It's how is it optimized, again, for that application to make sure that it works like it's supposed to. And that's really, I think, the big thing as you go through it is how do you optimize and be more efficient with these tools that we have, that maybe just think about it in a different way than we've done before.
That's great. I want to come back to this and maybe talk about some layering other technologies on, again, to even increase efficiencies. But we're going to take a little moment and hear from our sponsors, and we will be back momentarily. And we are back talking to Ron Mann, Vice President of Modular Systems at TDIndustries. So you've been talking about, the evolution and really optimizing and making these data centers much more efficient, and that work continues. Are you seeing, AI being deployed? And, I've heard a lot of, balancing around redundancies and leveraging AI to do that. You're saying some of these servers are at 95% capacity. How do you maintain critical uptime while offloading or managing compute?
Yeah, it's a good question. And artificial intelligence is becoming a lot bigger part of the equation as people find more ways to use it. Another thing you'll hear is you hear edge a lot, and we talked about that earlier, but edge is also it's really about latency of data, getting the data closer to the end user so that they don't have latency. And that's why edge comes into play. And edge means different things to different people. For example, if you talk to a hyperscale guy, an edge data center might be a 40 megawatt data center. You talk to a small medium business, it's 10 megawatts down the road, right? But it's all getting the data closer to the end user. And so what happens is in these systems is they're optimized is how do you back it up? How do you make sure that you have the uptime? A lot of customers today have software redundancy versus hardware. So they might have two modules that they're running, and if one goes down, they just switch it to the other module, right? Or things like that, or other parts of the data center. So that's kind of an evolving way. So there's a lot more software integration with the AI and the intelligence and what happens. One thing the thing about a modular environment is the reaction time is a lot quicker. For example, if you're in a module and say you're running, I don't know, half a megawatt in a module of IT, it's all in enclosed space, right? And that's what I call closed loop cooling or closed loop IT. And what happens in that environment? Well, let's step back a moment and just talk about an example. Let's say you're in a conference room. You and I are in a conference room. It's built for say 15 people. It's just you and me. It's in the summer in July here in Houston. If the power goes out or the AC goes out, we may not know it for a couple of hours because it's just two of us and it's built for 15, right? And that's sort of like how a data center operates, right? A data center can lose a crack or a cray and still have enough cooling to cool stuff, and they're only 7-8 kilowatts a rack anyway. Now, if you're in a module and you lose and you depend on the redundancy n plus one, and you lose a cooling, then it's going to start heating up pretty quick because you're in that closed loop space. That's why it's more efficient. You're not cooling extra space. You're just cooling what the IT needs, right? And the analogy there is like if you're in a car going to lunch in here in Houston, Texas in July, and the AC goes out, we're going to know it really quick. We're going to get out of that car. And so that's the difference. And so a lot of this has to do with how you react to failure, right? So you build in redundancy, n plus one. What's that mean? What's your redundancy? Is it your AC cooling? Is it in your communication? How do you proactively communicate what's going on in that environment so you can proactively account for it? How do you effectively change with the load of the IT? That's another big thing. When the load goes up, so you're running payroll at night, right? Or it goes down, you want to be able to match that with that's how you optimize to save money. You want to optimize the infrastructure load with what you're doing with the IT load, so you're not wasting anything, right? Don't over provision, don't under provision. Those types of efficiencies, if you do these things right, I think a key thing going forward, because you're not wasting anything. I mean, it's not overpowered and underpowered, and that's where I think a lot of the innovation will come, is how you optimize for that application.
And how has, blockchain, and especially just like individual miners who are now putting racks of servers in their basement, you kind of have to be in like Wisconsin because, the heat generated from those, that is probably the definition of inefficiency. Do you see that becoming productized? Not necessarily, obviously from TDIndustries, but I have seen companies that are starting to do mining as a service, blockchain as a service. How has that impacted the industry? Is that pushing things forward, or because there's so much experimentation with individual miners, do you see that there might be some dangers that we're missing?
Yeah, it's interesting. I think it's an interesting time in that industry. It's definitely in its infancy. My experience in that space is the miners are so expensive, and how and they don't really want to pay for the infrastructure. That's why you see a lot of free air cooling and things like that in these modules, and why shipping containers are used and modified is they're just trying to get something in there. And these things are going full bore, 98, 100% utilization all day, all night. And so they use a lot of what's called free air cooling, where it's just ambient air. And you're right, the part of the country you're in makes a difference. So I think a lot of people are finding that out, like we've had people put those kind of things even here in Texas. And, it's one thing when you're in the December weather here in Texas, it's another when you're in the July weather of how those things operate. But I think it's evolving. There's a lot of interest now in single phase immersion for crypto miners, where you put it into a fluid. Because it's more energy efficient. There's the problem you get into with some of these miners, especially if they're using fans for the air cooling, is they get really loud. When you think about these modules can be 1 or 2 megawatts. Think about that, 1 or 2 megawatts in a single module, and you've got 100 of those running somewhere. It can be pretty noisy for the dB level. So all that I think is kind of happened. I just think it's a little bit still the wild west in the crypto space, and a lot of things are doing. But it's definitely a lot more. I think we've been doing it the modules in the IT space, enterprise class space, for probably 15 years now. So it's we've done a lot of things. We've tried things that worked and didn't work. But I think eventually the crypto space will have to come along somewhere. I don't think it'll be as redundant and sensitive as an enterprise class type of application would be, but it will definitely, I think, come a little bit more towards the center of redundancies and things like that. Because a lot of these guys don't even have redundancies or anything; they just shut down.
Yeah. Sometimes some of them do it on purpose. So,
yeah. the next to some green energy will do that. They'll actually get paid to shut down, right? So that's part of the model that makes it attractive to them. So it's an interesting industry, but I think it's got a ways to go before it gets to a point where it's a little more mature and more standardized.
Yeah, I agree. So let's take a little trip to the future before we close out here. I'm going to ask you the question that I ask everyone. If you could project yourself 20, 25 years into the future, and you could bring with you any product or services that, that would just make you or your life personally happy, what would it be and what would it do?
I was thinking about that, and there's a couple of choices. Obviously, we look back and think, oh man, if I had a transporter, I wouldn't have to drive anywhere. That would be pretty cool. But I think the other one, as I get older, is again the sci-fi thing is nanites. I would love to be able to take a pill or an injection of nanites that would just repair your body on the fly, keep it going, do this, do that. And just if you read any science fiction, that's a lot you'll see is how these nanites just repair stuff, right? I just keep it going for another 50, 60 years. So that would be what I would go for.
That's great. Well, you are going to get your wish. There's a lot of work being done on that with digital therapeutics, digital pills that, subcutaneous, just little chips that kind of monitor everything and release medications. So you may get your wish before 20 years. Who knows?
That would be great.
Ron, thank you so much for joining us today and sharing your insights. It was an absolute pleasure speaking with you.
Thank you very much. I enjoyed it.